on the right.
Which one? This?
This part, yeah.
Oh, this is just the group chat for the meeting.
Oh, okay, okay.
Yeah,
All
all
right,
this
then
is the
continue.
Zoom stuff. Because I put it on screen share, yeah? Okay. Anyway, I'll get back to the questions in a bit. Let me just start with the basics. Okay, before I go on to any of the coding and everything, what you see right now, this screen is called a Jupyter Notebook. So if you see a normal IDE or text editor, which you see, it'll be like this. So something like you can code directly on this, you can type. Even in college or whatever, you might have seen people using something like this. So this is Atom, or you can use Visual Studio Code or whatever. But for data science, mostly people use something called a Jupyter Notebook. So why? Because it's easier to use, and plus you can see the outputs along with the code itself. So you can interact with your outputs. So all these are outputs, which I will explain eventually. But the point is you can interact with your outputs, you can see them, and most importantly, all of this will be stored. So unlike a normal coding editor where if you, after you're done with the code, you have to save the output separately, on this, the code along with the outputs is saved at once. So it's very useful for data science because when you're making, say, for example, I'll scroll a bit ahead just as an example. If you're, say, making any graphs, you can see the graphs directly along with your code. So this is the code for the graph. Again, all these I'll explain when the time comes. For now, just have a look at the environment and see probably why we use this instead of the standard Atom editor. Yeah, please put your mic off, guys, because it's a little irritating for everyone else if there's a sound. Yeah, thank you. Yeah. Also, if you guys have any doubts, just put it on the chat. I'll answer them as and when I stop explaining. So just keep, yeah, just keep posting the queries on the chat. I'll try to explain all of them that I can. Okay, great. So let's start with the basic thing, the installation. So first thing you need is Conda. So Conda is a package manager. So you've probably heard of pip or something where you have to install the Jupyter Notebook and all these packages. So depending on which system you're on, Windows, Linux, Mac, this basically covers all the systems. Linux is all the stuff like Ubuntu and all the related distros. Mac and Linux have almost the same installation. So I'll just show you an example. I obviously have installed it already, so I can't do it again, but I'll show you how it works. So once you click any of these links, I'll put up this notebook as well. So once you click, yeah, okay, I'll just copy paste. Just do this later. I'll send you this whole notebook and all the links later. For now, just look at it, listen, and then don't worry about that. You'll get all the links and the examples. Great. Okay, so once you click on, the steps are almost the same for all three of the operating systems, but I guess majority of you will have Windows, so I'll show you the Windows one. So once you go to this website, you can ignore all this. Just click this, don't download the mini Conda installer, download the Anaconda installer. There is a difference, but this one's better. So the point is, once you do that, just click download here, and that'll be done. Then just follow the steps here. They show on the installer. Again, it's a Windows thing, and I'm using a Linux system, so I can't show you that. Um, as for Linux and Mac, if any of you have Ubuntu systems, you just again download this and then just run this for Anaconda, and that's it. You'll be done with installing Conda. Uh, why it's useful is because once you have Conda, you can easily install all of this. You can install any Python package. You can install any these libraries which you would need later for data science, even machine learning, all of that. It's the first thing you need to install. And without this, you kind of can't install Jupyter Notebook either. So it's a prerequisite to starting the code more of. Okay, once you have Conda done, we have to install Jupyter Notebook. So this thing is Jupyter Notebook. Jupyter Lab is the next version of Jupyter Notebook, but it's not fully ready yet. It's in beta, you can say. I still use it, but I mean, you can stick to Jupyter Notebook. It's totally fine. They do the same thing to an extent. Okay, so I'll show you how to install that as well. Again, I will give you the links, so you don't really have to remember any of it, but I'll just show you because it's easier to install it once you've seen how it works. Okay, so just go on this link to install Jupyter Notebook. Don't install Jupyter Lab for now. Install the classic Jupyter Notebook, this thing here. So all you have to do is on Windows, you have to open something called the Anaconda prompt. That's the Anaconda prompt. On Windows, once you install the Conda, you will get this as an app. So once you do that, then you can type, just copy paste this. If you have a Linux system, then just open your bash, which is this. This is your terminal. Once you open your terminal, you can just copy paste this, which it shows here. Just copy paste this and then run the command. That's about it. If I run the same thing, since I already have it installed, it will show me that it's done already. Um, yeah, it's showing not found because it's a different environment. Okay, why do we install Conda again? It's because eventually in data science, you will be working with many projects at once. So this is one project and it'll need different libraries. Maybe you will work on something else and that'll need different libraries. Sometimes, especially when you're in production or when you're like making a specific app at the end of the day, after you're done with learning, you will need to probably send it to somebody. So when you do that, you need that person to also have the same files that you do, the same packages that you do. So to do that, we use Conda to make what's called an environment. So it's called an environment. Again, you don't really need this right now because Conda comes with a default environment. But I mean, Anaconda, yeah, if you install Anaconda, Jupyter comes with it. But on Linux and Mac, you don't really need the whole Anaconda thing. So Anaconda is like a what do you call it? An interface version of Conda. So if I search for Anaconda, I won't get anything on mine because I haven't installed the whole thing. If you want, that's an easier way of doing it, I guess. But personally, I don't find that very intuitive because it installs too many things which you will honestly never need. Yeah, just share the links in the group. I'll send you this notebook and all the links later anyway. But yeah, that would be great. Okay, so once you have run the install Jupyter command, I'll show you how to run this as well. Again, you can find all these online, but it's probably better once I show you how it works. Okay, just give it a sec. Yeah. So this was just one small command I've written for myself. That's unnecessary. Can you just is someone saying anything? I can't hear you. Just put it on the chat, please. Okay, anyway, I'll continue with that. Okay, so once you are done installing Jupyter Notebook and Conda, you go to your terminal or Anaconda prompt. Anaconda prompt is the terminal version for Windows. So Windows didn't really have this screen, this black screen before. Navigator is just the name of the application. So it comes with the Anaconda prompt and other features. So it's just an interface. You don't really need it. Okay, so how you use this is that after you're done installing everything, just go to your Anaconda prompt if you're on Windows. On Linux or Mac, you're not going to get an Anaconda prompt. So just go to your terminal. So just open a new terminal. And then you have to type Jupyter Notebook. Uh, guys, can you please just mute your audio? Thank you. Yeah, so once you type Jupyter Notebook and hit enter, you will see this opening. This is basically, you can think of this as another file manager like Windows Explorer or something. Why you would use this is that from this you can install, yeah, prompt is the terminal actually. Yeah. So once you have this ready, then you can start making the notebooks. So what you would do is you click new and then you click Python 3 or Python 2 or whatever you have. So it will create a separate notebook here. And if you see here, it has added this notebook. So it's called a notebook because you can mess around with it. Yeah, that's great. Thanks, Rohit. Um, Once you have this ready, I've already made this before, but again, you can start off with it normally. If I make a new notebook here, then you can add code. So this would be like your normal Python editor. So it'll be the same as if I open this editor here, Atom or Sublime Text, or I guess many colleges use Genie, so something like that. You can do everything that you could do there as well. So even if I wanted to write a small thing here, 3, if you see it works properly. No, you can't do it on the Windows prompt because Windows doesn't really play well with Anaconda directly. Uh, and you can't really see outputs. So if you see these things here, just as an example, if you see these, none of this is going to come on your command prompt because these are all pictures, images, interactive plots, and command prompt only supports text. So you could probably do all this, but then you won't be able to save it and you can't interact with it. So if you see the command prompt thing, just as an example, it'll be something like this. I don't need this. Um, this will be your command prompt. So I can probably still do the same thing. But if you see, I have to keep typing everything again and again. I can't, if I make a variable here, I can't directly use it and I can't save this anywhere. So this just doesn't work in the way of the notebook. So this is more preferred. Plus, it's just easier to use, honestly. And no one, you can't actually write proper codes and save them from the terminal or the Windows prompt. Okay. But before I go to the coding part of it, I want to talk a little bit about data science. So in general, you'll find a lot of definitions for data science online, but according to me, data science is just taking existing data or maybe collecting it. But the point is, once you have data, you have to get something out of it. Just having an Excel sheet isn't really going to do you any good. And where it's used is that in every company, there's a lot of data generated. So even if you take something as basic as, I don't know, Zomato, you'll have a data of a lot of people, what they're ordering, when they're ordering, how they're ordering it, if they're paying by card, cash, all that. And then from this, you can understand which products or which food items the restaurants have to make more, just as an example. So it's used in companies for optimizing, um, adding more value, selling more, and basically that's just one small aspect of it. Apart from that, it's used for a lot of things. So if you open this website called Kaggle, I will talk about this later. If you open Kaggle, you'll find a list of all the problems that are being solved with this. To an extent, this also deals with machine learning, but just as an example, even if you see the coronavirus thing, there's many people who are also working on data science projects related to this. Maybe if we have time, I will show you a few more examples. That's for later. Okay. What else we are going to talk about today is how to start with data science. How do you, what courses do you do and all that. Again, all the links I'll put up in the groups and maybe other people will also do. But just to show you guys the basics and maybe just show you around so you get used to the systems and how people in data science go through things. Um, the first thing is to get the data. Even before you start anything, you need to get the data. And there's many places to get data from. In For a majority of cases, you can start with Kaggle. Again, I'll put up the links. So kaggle.com. Yeah, sure. I'll just close all this. I've just been keeping all this on so people keep joining and I can have them. Yeah. Okay. Great. So in Kaggle here, you can go to datasets, and then basically you can see all. Wait, still loading. So all of these are datasets where you can get the data. So I can search for almost anything. I can search for plant, say, and I can get datasets related to plants. Uh, there's plant seedlings, plant village, plant disease, all this. And then once you have this, then you can actually start working on the data. But this is the first step. Um, there are other places to get data as well. There's one more which is very new. It's called dataset search. Again, I'll put up all these links later on the groups. Okay, so this is made by Google. You can treat it as a Google search, and this gets data sets from all over the internet. So if you can't find something on Kaggle, you can search for it here. Just as an example, I think this is a better way of getting data for stuff you need. Okay, now that you have the data, you need to um, first identify what you want with it, which is the most important part. So this is called identifying the target. And the whole point is any data set, anything you pick up, be it plants, I don't know, corona, steel, anything you pick up. Please stop drawing on the screen. Yeah, just please stop drawing on the screen. Thank you. Uh, any data that you pick up, you need to first identify what you want with it. So just as an example, this notebook is on mental health analysis. So it's another data set from Kaggle. So I'll show you the data set. So it's a mental health survey. Again, I'm just showing you this as an example. So you get how people who are working with it go through a pipeline or go through the steps basically, which we follow. So first thing I did was go to Kaggle, download this. So you can just download the data directly. This shows you what the data looks like. So as you can see, it's a table. Um, you can think of it as an Excel sheet or just data. So each of these are some columns, and then there's some information about them in the columns. So this is what a normal data set would look like for machine learning or data science. Mostly data science deals with these kind of data, tabular data, or uh, this is called a CSV file, or CSV file here. It just means comma separated values. And I'm just telling you for information. You don't need to specifically know about all this. Uh, so what I did is I first went to Kaggle. I downloaded the dataset. Now the second thing is you have to work with Python. So the question is, how do you get this data into Python? Uh, there are many packages to do that. Again, don't try to memorize anything. I will share all of this, and it's very easy to understand once you know what each of these things are doing. There's a lot of stuff in this notebook. I won't be covering all of them right now. I will share them with you, and later, if you want to get more information, I'll tell you, but it'll take a little more time than which we have. So, yeah. Um, okay, so the first thing which we do is import all these packages. So I'll explain what each of these do. This matplotlib and seaborn are stuff for visualization. So plots. So if you've seen these things, all of this, these are stuff which you can plot. So even if I wanted to just see what my data looks like, I'll be able to plot it. This is what these libraries are for. Pandas is the most important one, the most important one for you, because this is what helps you load this file into Python. So all I have to do is just run this one word, read CSV, and then this is just the name of the file. Once I have that, then if you see, I have, oh, sorry. This is a syntax to see if the file has worked properly. All it does is print the first two rows here. People generally do this to see if it's working properly or not. So Now you have the same file in Python, and you can do anything you want with it. Uh, uh, this whole notebook is actually a project which I had done. So I was trying to predict that given some of these factors, could you really say if the person might have a mental health disorder or not, something like depression or something. Again, it might be a little alien and foreign the first time you look at a notebook like this, but just try and see what I'm trying to do instead of remembering any of this. Because honestly, all of these syntax you don't need to memorize. You can find it online, or once or twice, if you do it, you'll be able to understand what I'm trying to do. In the meanwhile, guys, if you do have any questions, just please keep putting it on the chat. Uh, I will answer them as and when I can. Okay. The first thing which we have to see is explore the data. So if you guys had seen the syllabus which we were covering, the first thing we were doing is exploring the data itself and what we have. So once we load the file, we have to first see what it looks like, see what's there in the file, right? So this is the whole file. This is all the data I have. And these are just some examples of the values that I have along with my data. Okay. Why do we do all this? We do this because if you just look at it, this honestly makes no sense. And you can't get any information out of it. You can't do anything per se. So what we do is we first look at the data. We try to identify trends in it. We try to see the columns. So I've done a few things here to see the data. These are the list of all the columns I have. So if I just do data.columns, I can see a list of all the columns. You can ignore all these syntax. I've just written them in shorthand. This is just a for loop. This is just a simple for loop. So if anything looks complicated, I will explain it. That's fine. All this does is that now I can see all the data I have. So if I just pick any random one, how many employees does your company or organization have? So once you look at all these, you have a better understanding of the data. Because later, when you're in a company, when you're doing a job or an internship, no one's really going to sit and explain all this to you, explain the data to you. They won't, they will probably not even tell you that, this is what, this column is what. They will just give you this. You will just be given this file, and then you will be asked to predict something or explain something from the file. That's all the information you will get. So you will only be able to make sense out of it if you have some prior practice. So I'm just showing you the major pipeline that we follow. Okay, I'm just going to keep the chat open. This data set is something I have found on Kaggle. It's a mental health data set. It's called OSMI mental health. Again, I'll put up all these links on the chat. Don't worry about that. Okay. I just minimize the window. Okay, the second thing which I have done is pre-processing. So it's an extremely pre-processing. This is an extremely important part of data science. And the whole point is this is a very clean data set. So anything you get from Kaggle would be a very clean data set. But when you're doing a job in a company, you're not going to get a nice data set. What do I mean by nice data set? You'll find out. I'll give you an example while I'm at it. Okay. So the first thing we do is remove the missing values. What does that mean? So if you see this data set which we have something called NAN. NAN means that that value isn't there. So like the others have 1 or 6 to 25 or I don't know, just even a 0. We have to remove these values. There's many ways of doing it, but before you can just say, okay, let's just remove this whole row or remove the column, we have to first see how many of these missing values are there in every column. So how do we do that? Uh, this again, it might look very complicated, but all I'm doing is for all the numbers, I'm taking the whole data for every column. So suppose I take this column and I'm going through the whole data. I'm adding them all up, and then I'm seeing the number of times we have these NANs for every row, and then I'm trying to find the percentage of them. So if more than 50% of a column is empty, there is no need to keep it, because that will give you a bad or flawed answer when you're running other algorithms on it. So there's many ways of doing this. As you can, instead of just removing the whole thing, you can fill it up with the mean of the data set. So sum divided by total number of entries. But then again, all these things you can consider at a later point. Since this is just an introduction, I'm just walking you through the whole pipeline. Again, guys, I'm keeping the chat open here. So if you have any questions, just keep telling me and I'll be able to answer them one by one. Because it might look complicated the first time you see it. So, okay. So the first thing we do is remove the missing values or fill them up. Once we have that, if you see here, there are, out of the total number of columns, wait, I'll show you. The total number of columns here are 63 in the initial data set. No, you really don't need to memorize them. The more you practice, the more you will see that it's not needed to memorize. And if you see, most of these things are just what you want to do. So for example, drop means remove. So that's all I'm doing. I'm removing some of the columns from the data. So again, if you see, there's a lot of change here. Okay, if you see, initially I had 63 columns. Here it says 63 columns. Now I have 50 columns. 50 columns. Because the other ones which I removed are not needed. They are mostly empty, so there's really no point in us keeping them. Okay, this is one of the things which we do for pre-processing. The second thing, this is very data set specific. I've kept this because, again, you won't need to handle something like that right now. But if you do encounter it, then you will know what to do. So what happens is that if you take one of these columns, I will show you this column. So if you see this column over here in the initial data set, there's many things like this. So if you see, this says 6 to 25. 6 to 25 is not a number. It's a number. 6 to 25 is not a number, right? It's two numbers separated by a dash. So what do we have to do? We can't just take 6-25 because it's not a number. And all our algorithms just require numbers or decimals. So we can have 6.0, but I can't have, say, 6a or 6abc, or I can't even have something like yes or no. So the second step after filling missing values and handling this is all the categorical variables. So every variable, every column which has text and not numbers is called a categorical variable. So female, male, say, or sometimes, or no, I don't know, all the names of these places, US, UK, America, sometimes, all of these are categorical variables. How do we handle them? What I've done here is that I've tried to find out all the categorical variables. So why you would need to do this again is that later, even if you want to plot any of this, can you plot a text? You can't plot a text. This is just a few numbers which I'm plotting. So can you really plot something like age without any numbers to it? You can't, right? So we have to convert all our values to that. We have to convert all the values which we have. Sorry, just go there. Yeah, they have to convert all the values in the data set to numbers or decimal places. As you would probably know, decimals are called float in computer science. So you would either convert them into a decimal value, a float value, or an integer value. Okay. So once we handle all the missing values, you will still see that in the data set we have NaN. NaN is that because this value isn't there and we have to convert this into a number, we generally assign it a 0. Under in like basic conditions, you would assign it a 0. So the syntax of that is just very simple. You just do this, fill NA. So an NaN value or an NA value, and all I do is replace them with a 0. That's all I'm doing. Uh, Once I have this, then I have a clean data set. I have a data set where if you see here, it's the same thing, and all of these are zeros, and there are no NaNs in this data set. Again, we're doing this because we want to plot all these values. So yeah, okay, I'm just going to stop for a few seconds and do any if you have any questions so far, just please put it on the chat, because before we move on, I want to have this part clear. I'll give you guys a few seconds. If you do, just please put the questions on the group chat. No questions at all? Everyone's understood everything I said? Okay, yeah, cool. How did I handle 6 to 25? So this is the exact thing how I've handled 6 to 25. All I've done is that once there's something called unique. So this column, the column with this, how many employees does your have? So all I've done is that this has these ranges, but there are a finite number of them. So I identify the number, sorry. Yeah, so these are the unique values in this column. No, I didn't take a mean of this. I have replaced these with numbers. So for example, this was assigned 1, this was assigned 2, this was assigned 3. And then I have done something called normalization. I can't take mean of this. Maybe I could to some extent, but in this case, it was not necessary. See, there are many things which are very dependent on what you want to do. I took it as a categorical value. See, in this case, I have just treated all this as categorical values. 26 to 100 is 1, 6 to 25 is 1, because there's just these many ranges. And I don't need to take the average. Now, in this case, if these ranges were more than, say, 20 or 30, then I would have probably taken the average between these two values. Again, this is very dependent on what you want to do, your task per se, because majority of the times you will have an objective, you will have something which you want to fulfill, and to do that there are some things you need to do. In this case, my objective was not to predict a value directly with these columns initially, so I didn't take it as a mean. Sometimes you might need to. Again, if you have the question of how you would know, it's honestly practice, and sometimes you might have to test out 2-3 things to see which one works better. Cool. Any other questions, guys, before I move on to the next part? Yeah, you can use an encoder. And I didn't do it manually. I have used uh, something from Pandas. I will see if I can find it. Yeah, so I have used this is an encoder. So .cat.codes. So if you want, I can show you an example with this. Yeah, if I take the same column, this is what I have. And I can do, again, don't try to memorize all the syntax. Yeah. Once I do that, then I can do cat.codes and it'll give me these values. So no, I haven't done it manually. I've just used something from Pandas. Now, all of these are part of the Pandas library. So if you want to do any of this, you can do it manually as well. But I mean, why would you? If you can do it with just one line of code. And you can even see the values. Yeah, you can see the values. Once you have done this, you can even see the labels. I am not sure of the syntax, so it could be labels, maybe. Again, if you see, even I don't exactly memorize these syntaxes. For anything, any library, you can refer to the documentation. So I will just show you the documentation. So um, Pandas itself has a very great documentation. You can look at the getting started guide and it'll show you all the basic stuff which you need to do. So, I mean, if you want to learn, you can learn it from here as well. You don't obviously need to know everything, but all the stuff that you need for your project, you can find here. Again, I'll put up all these links. Yeah, it's similar to encoders. It is an encoder, actually. This is an encoder. And then if you want to decode it, then once you take this cat dot codes, you can find the labels from it, like the initial labels. Shubham, did you get it? Okay. Any other questions? Okay, cool. Any other questions, the rest of you? You can ask me if you didn't understand anything. If you want me to explain anything again, I can do that. Okay, cool. Um, the next thing which we will look at today, according to the syllabus which we've sent you, I didn't drop all the records with NAN. I dropped some of them because more than 50% of this column had an NAN value. So 50% is a good value because that's like saying half the entries in this data set are not there. If half the entries in a column is not there, then there's really no point in keeping it. Okay, as type. So this is a shorthand in Python. So this is my initial data, right? If you see, these are the values. Once I do, once I run this, all I have done is I've converted this into string values. So now this is not a number, it's a text. So even the zeros, these are now text values. Once I do that, then I can assign them labels. So if you see, there's so there's just these many unique values in this column. So all I have done is I've assigned each of this a unique number because again, as I mentioned, we need numbers at the end of the day, and this is just one way of doing it. There's many ways of doing this with pandas, but personally, this is the easiest one. You can use label encoders, which is another feature of pandas and all that. It's a feature of sklearn, actually. That's another library. Again, because you can do all this with pandas, I am not going to show you every single way of doing it. It's not necessary, honestly. You can just pick anything you find easier, and then you can stick with it. Okay. Okay, I will continue with it. If you guys have any questions on the way, just keep sending me on the chat. I will answer them. Okay, the next thing which we will look at is something called binning. So why would you need something like this? I will show you an example. Suppose you have a list. Okay, again, this is just a shorthand syntax. Suppose you have this as a list. It's just a list of random numbers from 2 to 100. I've just taken a few numbers. There's 33 numbers which I've taken. You can do this with a simple for loop as well. So you can, I can append this to a list. So this is just a shorthand way of doing it instead of having to write the whole loop statement. Okay, so sometimes you don't need it specifically for this example, which is why I'm making my own list. Sometimes what you need to do is you need to split this data set into parts. So suppose I want 4 parts. I want my data set, this whole thing, to be in 4 parts. So that is called binning. And you can do that very easily with this function called cut. So if you see this part, this is just my array. So this is not part of the syntax. This much is just my list or array. np.array is actually another syntax. So there's a library called Numpy. NumPy, and it's just numerical Python. So anything you want to work with numbers. So for example, if I have this list and I want to find the average or the mean of this list, all I have to do is write np.mean. Similarly, if I want to find standard deviation, I can just do that. And this is my standard deviation. So it's just a library which will allow me to work and get some stuff done very easily. Generally, you would have to write the whole formula for standard deviation and even for mean. And if you see, there's a lot of things you can do with it. So you can find the max value from this. So the max value here is 90. If I want the min, I can do that as well. 2. There's a small list, so you can see it. But if I have something like, no, it doesn't work on a normal list, which is why I've converted into a NumPy array. So a normal list, actually what NumPy does is that it parallelizes the list. So it basically makes it faster. It changes into a different data type. So because I can't run these things on a normal array, I've converted it into a NumPy array. But some functions work, like something like standard deviation, min, max, all these things work directly. Not all the stuff, not all the NumPy functions can work on a list. Generally, it's just better to convert it. Yeah, I guess. Okay, guys, if you can't see the questions, just click the to feature in the chat and then just click everyone in the meeting instead of sending it to me privately. Because I think everyone who's asked me is asking me the questions privately and not to the group. So just click this thing here too and make it everyone. Yeah, I'll explain this line. Okay, so as I was saying, right now our objective is to take this array, this list or array or whatever, and divide it into n parts. So suppose I have, say, 1, 2, 3, 4, 5, and someone tells me that instead of this, I will tell you where you would need it, but just as an example, instead of this, I need it in 2 parts. I need the first part with 1, 2. Okay, I'll just make it an even value. 1, 2, 3, and I want the second part with 4, 5, 6. So this is our objective. We need to convert this and split it into these many parts. Again, if you didn't have the 6, this would just be 4, 5. So if you want to write a loop to do it, it's really irritating and it'll take you a lot of time. You'll have to create separate loops. You'll have to create separate arrays, and then it won't be general and it'll be slow. So Pandas has an easier way of doing it. Again, I will explain all this one by one. So this part is just my array. So if you want, I can just take this array. I will just use this directly. Okay. Now the other thing which I need right now, I will copy this. I'll show it to you step by step. So I'll show you what each of these things do. Okay, so right now all I'm doing is I've given it this list and then I've said, okay, make it into 2 bins. This is also normalized it, which you don't really need to know right now. But the point is it's divided all these values into 2 parts. Again, these are normalized values. There are ways to unnormalize it, but generally you wouldn't need to do that. So even if you're applying this into the next step of the data science pipeline, this is more required. And which is why I've given this, because this will tell you the actual values in the data set. So it's been resized like this. So this is one part of it as an example. And right now I have divided into 2 parts. Again, this technique is called binning. You don't need it for all the stuff you do. It's generally not that used, but it's a good thing to know, because sometimes what happens is you might have a very huge array. You might have something of 3 million lines and you won't be able to use it all at once. If someone gives you, I don't know, 10 million rows in a data set, and if you have a very slow computer, this will take you a long time. and just for testing purposes, it's not necessary. So you would divide it. You would use pd.cut. You would divide it into, say, I don't know, 15 bins, probably make it into 15 parts, and then just work on the first part or the first three parts, two, three parts. Uh, Again, this is useful, but it's not always used. The next thing here, this is the next part. Red bins will basically just give you these values. So it will give you the bins separately. You can access them separately. That's all. Again, you generally don't need to. If you're ever using pd.cuts, you don't need this parameter. I've just shown it to you because it's easier to understand. When you're applying it in the data set itself, you don't need this. You can just change the data frame to this directly. Also, this is called a data frame. So instead of calling it a table, I can call it a data frame. It's just syntax, you can say. People call it a data frame. Pandas syntax, more of. So the whole point is, if you know that it's called a data frame, you can convert a list into a data frame. So for example, I can have pd.data frame. I hope I have the syntax right. Yeah. So this is become a data frame. I can give it multiple lists as well. And then if you see, I have this as a table. So if you know, now that you know it's called a data frame, this is a syntax to make anything into a data frame. Okay. This is extremely important, normalization. Um, okay, if I want to put it very, very simply, if I have values like this, 1, 2, 3, and the next value I have is 10,000, and the next one I have is, I don't know, I'm just going to put a bunch of zeros. So what happens is, when you're applying a normal statistics thing to it, so for example, I convert this into S. Suppose I just do mean of this. If you see, it's a very huge value, but these things are very small. So what happens is, later when you're applying something like visualization, so if I want to plot these values, I will see that my graph will be very small. I have a feeling Zoom has a whiteboard option. Okay, so if I say have a graph and I want to plot these values, if you see, it'll just be very small. So this will be here and the other ones will be here. So even if you're trying to draw a line through it, it's almost impossible. And later when you're working with data science, it becomes very, very irritating. Okay, how do you close this? Okay. So what we do is that we normalize these values. Okay, yeah. Okay, so what is normalization? I will show you the definition. More of, I'll show you the formula. Okay, so all we're doing is this. I wanted to show you this so you can understand what we are trying to do. So my x min is the least value in my table here, so that's 1. My x max is this value here. So the whole point is that I want to convert my values into, all the values should be between 2. You can't see the screen? Oh, okay, I will. Is the screen back now? Okay, great. I think the whiteboard had removed it. Okay. Yeah, so what I'm trying to do is that if I take yeah, I have x, which is my current value. So if I want to normalize, say 1, right? I take x. My x min, again, here is 1. My x max is this value. The whole point is that I need to convert all of these values into values between two numbers. Now, generally, instead of having something like numbers between 1 to this huge value, I would convert it into numbers between -1 to 1. So you can also do it from 0 to 1. But then if you take -1 to 1, it's just statistically better. So again, you might have studied this in some way in statistics, some way. I am not sure if you have. I hope you have. If not, it's fine. The whole point is, I will try to show you. Okay. I'm gonna try to put the whiteboard again, and I might just have to put the screen back. Okay, forget it. The screen keeps going if I try to put the whiteboard. Yeah. Can you guys see this? Okay, cool. So what I'm trying to do is that right now, if this is my graph and I have some values here, I have some values here, some values here, some values here. And then I have some values which are here. So if I have like 3 values which are here, obviously this is one whole group. This is a separate group. And if I want to say draw a line through them, or if I want to identify some form of pattern, it's almost impossible for me to do because all of these are on literally different scales. So what I have to do right now is that, see, for example, if I try to draw a line here, this is one scale, and then this is on another scale. So what I have to do is that I have to, instead of doing this, if I put all my values here, so if I put all my values over here, it's easier for my algorithm to find out all these points because it's in a smaller range. So, okay, one sec, I will put the share back. Yeah. So all I'm doing is that right now I'm converting all my values into values between -1 to 1. So in this case, if you want, I'll take this number. So there are different values of normalization. This is one form of normalization. This is just min-max normalization. What you're talking about is another normalization. Again, if you look at the formulas, you'll find many types of normalization, which is why even if you see the pandas documentation, there's many types of scaling, many types of normalization. If you want, I can show you. Yeah, so guys, please mute your audio. So if you see, there's a lot of types of normalization. I don't think this is mentioned exactly. But the point is pandas in itself has a lot of these scalars. So if you search for scalars of pandas, you'll find min-max scalar. You'll find others. You'll find ones with this formula, mean by variance, val minus mean by variance formula. But this is just another scaling. So this is used to reshape it between two values. What you're saying it won't give you these values. So also, if anyone's sending me any questions, can you send it to everyone instead of just me privately? That would be nice. So then everyone can see the screen. Okay. Yeah. So if I run it on this, if you see all these values are between -1 and 1. Initially we had this value. This value has become this. It's become 1. Because this was the least value, this has become 0. And then the other values are between these, between 0 and 1. So this is what this does. Again, if I put a random big value here, suppose I put 200. So if you see, this value is bigger than this. But all of these are still in between -1 to 1. Once we have this, we are done with a majority, we're done with a part of pre-processing. And then we can actually look at our data. Okay, so before we go there, any other questions, guys? What anything you've not understood so far? Uh, just please put it on the chat so I can explain, and send it to everyone so everyone can see the questions. Okay, no doubts at all. Mm, okay, fine. I will continue with it. Okay, so we have mostly covered whatever we were supposed to teach today. Um, I will show you the rest of the pipeline. So this is also a machine learning project and not just a data science project. So as I had mentioned when I started off, I was trying to predict if given a bunch of factors, someone has a mental illness, given all this whole table. So if you give me this whole row, I'll be able to predict a value. Normalization or standard? No, normalization and standardization are part of the cleaning. They're one of the pre-processing techniques which you would need. You can't do it after you apply an algorithm because if you do, then there's really no point. So you would do all this as part of the cleaning. If you want, I will list them down. So everything which we have covered so far in pre-processing. We first have fill missing values. Then we have just have a basic look at the data. Then you remove the columns with a greater percentage of missing values. After that, you have standardization and then normalization and everything which I have talked about right now. Majority, it's this, and then you specific to the data set, you might have to fix some columns. Uh, but then again, that depends. That actually depends on your data. And then because as I was saying, if you remember, there was some like 6,25, something like that. These things you would have to fix specifically for the data set. Okay. Anything else? Okay. Feature engineering is the next step after this. That's a good question. Feature engineering is probably used is it not probably it is used to select which of these columns you would use. So I will show you an example probably in this data set itself. Okay, so if you take something like this column, just a random column, the whole point is would you use this column for your data or would you remove it? That is the whole point of feature engineering. So if you see the missing values part of it, um, dimensionality reduction is something else. It's not really needed here right now. Um, Dimensionality reduction is like a little more advanced thing, which I didn't think I would cover. But since you asked, if you have a lot of data, so if you have something like 2,000, 3,000 columns, or if you have something like images instead of just text. So if you have each image represented in this column or a row, it's not possible for you to apply some of the standard algorithms. So what you would do is that if you have a 1,000 column table, you can reduce it down to 100 columns or 200, which would make it easier for your algorithm to run. Generally, it's used for something like face recognition to an end. In some aspects, if there are sometimes you have 30,000 columns or something in the data set, that you might need dimensionality reduction. Then again, you don't need it for these things. It's just when your data is extremely huge. You wouldn't need that at this stage. That's for later. Yeah, I'll send you. Actually, I can't send you the link. It's on GitHub, actually. So yeah, I'll send the GitHub link. Okay, so for those of you who have not used GitHub before, okay, GitHub is a code sharing platform, and you can save your code and then view other people's codes. I keep uploading all my projects to it, so it's just easier for me to look at it. I will send you this link on the group. Uh, this link, I'll put it up so you guys can download this notebook. Once you download it, just navigate to that exact part from this interface and then click it, it'll open. So if I just click it, it'll open. I've already opened it. I will send you guys all the notebooks and everything I've shown you so far. Don't worry about it. If I will send you this link, so all you have to do is go on this link, click this file, mental health. So this is the extension of Jupyter Notebook, IPYNB. It's just called an IPython notebook. I mean, it's important if you want to look at other people's stuff and see it. So if you click it, you can view it directly on GitHub, but it doesn't load sometimes if the files are too big. Okay, it worked properly. So this is exactly the file I was showing you just now. Guys, can you please mute your audio? Yeah, thank you. Okay. Now whatever I'm showing you is not part of the portions, and I won't really be explaining it properly right now. In later sessions, I think me or one of the other mentors will explain it. I'll show it to you now, so the next time you see it, you'll be able to see how it links up with everything I've shown you. So whatever we have done so far is EDA, which is called exploratory data analysis. I will write it down. Exploratory data analysis. Yeah, so everything which we have done so far is this exploratory data analysis. Um, Even these things, the plots and all this is also part of EDA. Again, I think we will be covering plots and everything in a future session, but just have a look and see the kinds of stuff you generally do with data. So by now you have reasonably cleaned up the data. You can use it, you can work with it. So now it's time to understand what the data looks like in terms of plots. So I've just done a few plots based on them. So I'll just show you an example. We take one of the columns. So what country do you live in? And then I want to see the distribution of people. So say, for example, how many people in the US or the UK have a mental health disorder. Again, you can ignore all these syntaxes later. Maybe we'll explain them at some other point. But the whole thing I'm trying to do here is that I'm trying to identify which country the people live in, and then I'm trying to plot them. And if they have a disorder, that's all. So, and I make it into a bar graph. So if you see, sadly, US has the maximum number of people. So if I want, I can show you a subset of this. So I think that's easier to see. Again, this whole thing, this plot is something called Plotly. It's a library, just like Matplotlib and Seaborn, which I had shown you initially. So it's just like these. It's just like these. But the whole thing is Plotly allows you to interact with your plots. So this same plot, I can actually export it and save it as an HTML. So the whole thing is right now, if I want, I can open this on my browser. So this is just a normal browser window. Again, you don't really need to do this right now, but uh, now that you've seen it, you know how it works. So sometimes you might see some websites which have used something like this. So this was done with Plotly, and all they've done is exported this into an HTML. Okay, to continue this, all I do is that I first put these plots. So now that I have plotted this, I can infer stuff. Infer as in now I can look at my data and say that what do I learn? What do I learn from this column? Right now, what do I learn from this column is that places like Estonia, they don't really have that many people who say they have a mental health disorder. But if I take this whole subset, then I can, sorry, if I can take this subset, then among these countries, now I can say which one has the most, which one has the least. You can, again, if you want to know, you can do this with numbers itself, but sometimes it's not possible because if all these are decimal values, and more importantly, if you have a lot of values. This is a very small data set, but if you have something like 30, 40,000 values and they don't fit properly like this. So for example, if you take some values which you might want to view them as a pie chart, and it's just easier to see them as a pie chart than just look at numbers. If someone just says 197.33, that means nothing. Honestly, it means nothing. So if you put them in a pie chart, you can interact with the data. You can see, it's just easier to understand stuff from the data you have. Again, I would like to iterate that the whole point of this is that um, you identify stuff from the data, you extract value from it, and you use it. You get something out of the data you have. After you do all these plots, so all of these stuff are things which are found from the data. So these are all different types of plots. Again, you won't need to know them now. Either me or someone else will explain all of this in some later session. All of these are just types of plots. I'm showing them to you again, as I said, just to see the kind of stuff you would do. Okay, this is a machine learning part of it. To be honest, it's also part of data science. So I have used algorithms to find a value. So this is my accuracy, and I've tried to increase accuracy by using different values. The whole point of this is that once I have my data, I'm trying to identify as many factors of importance as I can from them. So this is just one way of doing it. Okay, guys, I'm done with the material for today. So I'll hang around for a bit. Feel free to ask me any of the questions. No, you don't need to know all the plots. So if you want, I can show you this website, Plotly. So these guys sort of list down um, all the plots they have. I will show it to you. So if you see the Python plots, these are all the kinds of plots that you can get. You don't really need to remember all of them. So just look at the documentation. But what you would need to do is you would need to understand which one to use when. So obviously, if I have something like the kind of data here, like if I have age, there is no point in me picking up a map, because obviously how that makes no sense. So there are many things here which you would need to know why. So something like scientific charts is used for a specific thing. So overall, you would just need to know what each of these are for. You can look at the documentation itself. So if I say want to know what a heat map is, if I click that, then it'll show me a code and it'll show me an example. And it has a little bit of explanation. Again, you don't really need to remember any of this. You just probably need to know what each of these are. Yeah, I will show you guys the source for it. Again, the whole content today is the source where I have learned from is the documentation. There are courses also. So there's one course called E2Z Data Science. Yeah, this course, Udemy. Uh, I'll send you all the links. So it's really not very expensive. Um, I I'm not sure if these guys teach it through Python because I have firstly not done this course, but you can learn the concepts from it. So generally, the way I learn is that I open one of these course websites, I look at their syllabus, and I try to learn all these things from YouTube. But then that's me, and it works out for me because I already have a base in this. If you guys are starting from scratch, then you can start with this. You can start with a few courses, and you should start with a few courses. Um, okay, cool. Any other questions, guys? Just feel free to ask me anything, even if I've not taught you that right now. I'll hang around for 15 minutes or so, and I'll try to explain. Um, no other questions? Okay, fine. If nobody has any other questions, then I will stop today's session. Thank you guys for attending. If you do have some other questions later, you can ask me on the WhatsApp group or just drop me a message. Thank you. Hope you learned something from it. Have a great day. I will end the chat now. Yeah, I will upload the recording link and I'll share it. Don't worry about that. I will just stop it at some point. Okay, cool. You're welcome. I hope you learned stuff and I hope you enjoyed the session. Just keep following the group. There's a lot of people there who you can learn from, and it's a good time because everyone's at home and you can learn a lot from them. So make best use of this time because honestly, you're not going to get it again. So it's a great thing that you guys attended the session. Hope you guys stick with it and then keep learning more stuff as the time goes by.